lecture, we will discuss sequence and series, which is also known as progression. Now, if you consider this progression, so there are three types of progression. One is termed as arithmetic progression, another is termed as geometric progression, and third is termed as harmonic progression. Now, as far as this arithmetic, geometric, and harmonic progressions are concerned, these different type of progressions are based on how the sequence or the series progresses. Suppose if you take this example, let us say 2, 4, 6, 8, and so on. So here if you observe 2 plus 2, that is 4, 4 plus 2 is 6, 6 plus 2, 8, and so on. It means that terms are moving in the forward direction with a common difference of 2, because here you can see 4 minus 2 it is 2, 6 minus 4 it is 2, 8 minus 6 it is 2, and so on. It means between the two consecutive terms the difference is same. So when the difference is same, and with that difference the terms are moving, or it is increasing in the increasing order, or it is in the decreasing order. We can, in the reverse way, we can write the same sequence as 8, 6, 4, 2, and so on. So here you can say 8 minus 6 it is 2, 6 minus 4 it is 2, 4 minus 2 it is 2. Here also the difference between the two consecutive terms it is same, but here it is in the ascending order, but here it is in the descending order. So if the sequence moves in this according to this rule, where the difference between the two consecutive terms are same, we call it as arithmetic progression. AP means arithmetic progression. Similarly, you can take another example which will justify this geometric progression. So if you take this example 2, 4, 8, 16, 32, and so on. So here you can see this relation between the terms. 2 into 2 it is 4, 4 into 2 it is 8, 8 into 2 it is 16, 16 into 2 it is 32, and so on. It means if you calculate the ratio between the two consecutive terms, you will find that is same. 4 by 2 it is 2, 8 by 4 it is 2, 16 by 8 it is 2, and so on. It means the ratio between the two consecutive terms it is same. So if any sequence or a series progresses in this manner, then that is termed as geometric progression. So here, the common ratio, this ratio we call it as the common ratio. The ratio between the two consecutive terms it is same, so it is called geometric progression. Difference between the two consecutive terms it was same, that was called as arithmetic progression. Now the third progression, we have it as harmonic progression. Harmonic progression is nothing but it is the reciprocal of this arithmetic progression. Arithmetic progression, just now we have observed that the difference between two consecutive terms it is same. Here, as far as the harmonic progression is concerned, each and every rule related to this which will remain same. The only thing is we have to consider the reciprocal of this arithmetic progression. So suppose if you say 2, 4, 6, 8, if they are in AP, that is arithmetic progression, then the reciprocal of each term. So we just consider a sequence which is nothing but the consequence of the reciprocal of this. So it will be 1 by 2, 1 by 4, 1 by 6, 1 by 8, and so on. Now if 2, 4, 6, 8 are in AP, then 1 by 2, 1 by 4, 1 by 6, 1 by 8 is in HP. So this is harmonic progression. So these are the different type of progression you can say, or you can say the sequence or the series that in general we call it. And these are the particular form of any sequence or series. There is arithmetic progression, harmonic progression, and geometric progression. So one by one we will discuss all these three progressions. Now here if we start with this arithmetic progression, so now just to generalize this, if we consider the first term, suppose A, And the common difference here, if we take it as D, as we have just defined, the difference between the two consecutive terms, it is same, which is termed as the common difference. So if you take the common difference of that sequence as D, first term as A, then what should be the second term? It should be A plus D. Third term, it should be A plus 2D. A plus D, because this difference between these two consecutive terms, it has to be same. So that we have taken as D. Difference between this and this, again it should be D. So A plus 2D minus A plus D, that will become D. So similarly you can say A plus 3D and so on. So first term is A, second A plus D, third A plus 2D, fourth it is A plus 3D, fourth it is A plus 3D. Now here it is factor 3, or the coefficient of D here you can say it is 3. Here coefficient of D it is 2. This is third term, but the coefficient is 2. This is fourth term, but the coefficient of D it is 3. This is second term, but the coefficient of D is 1. So from this, can you conclude if for nth term it should be A plus n minus 1 into D. Fourth term it is 3. Third term it is 2, so for nth term it should be how much? A n minus 1. So it becomes A plus n minus 1 into D. So this way we calculate the different value of the terms if it is in arithmetic progression. So from here you get a general relation that first term, second term, third term, and this gives you the nth term. So we say for arithmetic progression the nth term it is equal to A plus n minus 1 into D. So if you have a sequence which is in arithmetic progression, just using this relation you can calculate the value of any term, 5th term, 10th term, 15th term, or in general the nth term. So Tn it is equal to A plus n minus 1 into D. That's what you can see here. Now similarly corresponding to this, if we add all these terms, if you want to find the sum of these terms, so if you want to find the sum of these terms, let us say Sn, sum of n terms. So it will be A plus D plus A plus 2D plus A plus 3D and so on. So if we calculate it and simplify, you will get the sum of nth term, it is equal to n by 2, 2A plus n minus 1 into D. N by 2, 2A plus n minus 1 into n is the number of terms. We are calculating sum of n terms. So n is the number of terms, A is the first term, D is the common difference. So it can be represented as sum of n terms, n by 2 into 2A plus n minus 1 into D, which is also equal to n by 2, first term plus the last term, because here you can represent this as A plus n minus 1 into D. Now 2A, it is A plus A, n minus 1, so we have this n minus 1 here. Now A plus n minus 1 into D is what? The last term, yani nth term. A plus n minus 1 into D, it is the nth term or the last term. So this is replaced by last term, this is your first term, that's why we write it as first term plus the last term. So this way we can calculate either directly you can use this relation, or you can use this relation to calculate the sum of n terms. Now this relation you can use only when the sequence or the series it is strictly in arithmetic progression. If there is any deviation and if it is not in AP, then directly you can't use this relation. Then you have to find some other algebraic method to calculate the sum of all those terms in that sequence, because it is not particularly in AP. Now, if you see this here, suppose you can take, now just to simplify problem, you have to sometimes assume what should be the value of my first term, second term, third term. Just now as I have taken the first term A, second term A plus D, third term A plus 2D, and so on. Now to simplify different type of problems, sometimes we need some such kind of assumption which gives me the simple calculation. If in general we take value of any term without getting some relationship between them, then the solution may be very complicated. Just to have a simple calculation, we can take any assumption, there is no restriction about it. But just to make some calculation simpler, we have certain standard assumptions. And if we keep that in mind, our as a simplicity of that calculation, that will benefit us. So if suppose you have to assume 3 terms in an AP, so instead of assuming A plus D, A plus 2D, we will assume this. First term as A minus D, second term A, third term A plus D. Now, there is nothing wrong if I proceed taking this assumption. But if you take this assumption, the calculation part, it will be simpler. So it is better if there are 3 terms to be assumed, take the first term as A minus D, second term as A, third term as A plus D. Now you can see what is the benefit. Now suppose you have to find the sum of these 3 terms. So A minus D plus A plus D. So this A and A, 3A minus D and plus D, that gets cancelled, that gets eliminated. It means one unknown gets eliminated in this case. So that will give you some advantage as far as the calculation part is concerned. Similarly, if you have to assume suppose 4 terms in AP, 4 numbers in AP can be taken as A minus 3D, and the first term as A minus 3D, A minus D, A plus D, A plus 3D. You can see the common difference. We have not violated as far as the definition of arithmetic progression is concerned. A minus 3D plus 2D, that makes it A minus D. A minus D plus 2D, that gives you A plus D. A plus D plus 2D, that gives us A plus 3D, and so on. So it means here the common difference is 2D, not D. Common difference here it is 2D. So that way we have added. So these are some of the standard assumptions. So that calculation, repeatedly I am saying it is only for the advantage of calculation or simplicity. Similarly, you can consider 5 numbers in AP, that is A minus 2D, A minus D, A plus D, A plus 2D, and so on. If you have to assume 6 numbers, then it is A minus 5D, A minus 3D, A minus D, A plus D, A plus 3D, A plus. Here also the common difference, it is 2D, and so on. Here also you can see A minus 2D plus D. So here common difference is D. So depending, but mostly or commonly, we need to assume this 3 terms in AP, at the most 4 terms. 5, 6, generally they don't ask question based on this. So sometimes you will need this assumption, sometimes you will need this assumption. If you don't get all these things in your mind, there is nothing to worry. You assume whatever you want to assume, proceed and simplify the questions. Now let us see some of the properties you can see, or some of the feature or highlights of all this. The common difference can be 0, positive or negative. The common difference, it can be 0. It means in that case you will get a constant series. 0. It can be positive, it can be negative. If it is positive, you will get the ascending terms. If it is negative, you will get the sequence in the descending order. It means the increasing order or the decreasing order. The sum of the terms of an AP, equidistant from the beginning and end, is constant. Sum of the terms, let us say A1, A2, A3, dot, AN. These are your n terms of an AP. Sum of terms from the beginning. If you take suppose these 2 terms from the beginning, first and second, and 2 terms from the last, AN and AN minus 1. Sum of these 2 and sum of these 2, it will be same. Similarly, if you consider sum of these 2 terms and sum of these 2 terms, here you suppose you take AN minus 2, so these 2, it will be same. So the sum of the terms from the beginning, sum of the terms from the end, that will be same, because difference between the 2 consecutive terms, it always remains same. So difference between these 2 terms is same, difference between these 2 terms is same. So because of that, this relation holds true. The sum of the terms from equidistant from the beginning and end, it is constant and equal to the sum of the first and the last term. That is always equal to sum of the first term as well as the last term. So this is just the explanation of this. Now here you can see another property. If x is the pth term, as we have considered, Tn is equal to a plus n minus 1 into d. This is nth term. Similarly, pth term. So pth term, it will be how much? Tp. And that will be a plus p minus 1 into d. That is the pth term. Similarly, you can say yth term, z term, qth term. So qth term, it will be a plus q minus 1 into d. Yth term, a plus y minus 1 into d, and so on. So if x is the pth term, y is the qth term, and z is the rth term of an AP, then this relation holds true. That is x, y, z, p, q, r, 1, 1, 1, that is equal to 0. This is your determinant. So determinant x, y, z, p, q, r, 1, 1, 1, that is equal to 0. These are some of the properties. You may keep it in mind, you may not keep it in mind. Depending on the requirement, we can always calculate and we can have this kind of relation. So it is up to you. Because so many things we don't feel like keeping in our mind. We don't need to memorize all these things because we have to work as far as our mind is concerned. The basic concept is how the sequence is progressing, the nth term, how we get the nth term, how we get some of the nth term, and the rest of the things. If it is there in your mind, it will save your time. But if it is not there in your mind, suppose it does not come in your mind when you are trying to solve a problem, it hardly matters. I will calculate whatever is the basic relation from there, the basic concept, and from there onward, I will proceed further. Now let us see the next sequence, as we have just given a brief description of that, that is geometric progression. Now geometric progression, as we have just defined, it progresses with common ratio. Suppose 2, 4, 8, 16, 32, 64. Here the common ratio between the two, and the ratio between the two consecutive terms, it is same. 4 by 2, 8 by 4, 16 by 8, 32 by 16, and so on. So it is same. So this sequence, it will be termed as geometric progression. Now again, just to generalize, if you take first term as A and common ratio R, 4 by 2 it is 2 here, 8 by 4 it is 2. Just to generalize, let us take the common ratio as R. Then the second term, it should be what? AR. Third term, it should be how much? AR squared. Fourth term, it should be AR cubed. So what should be the nth term? It is AR and minus 1. AR to the power n minus 1. AR squared, AR cubed, dot, dot, AR to the power n minus 1. So this way we calculate the nth term. So nth term of the geometric series or geometric progression, it becomes Tn is equal to AR to the power n minus 1. That you can see here. AR squared, AR cubed. So that is these are the terms of the GP, where the first term is A and common ratio is R. Now, so from here you are getting nth term AR to the power n minus 1. Some of the first n terms again, if the sequence again is strictly, if it is in geometric progression, it has to be in geometric progression, then only you can use these relation. Then the sum of n terms, it is AR to the power n minus 1 upon R minus 1. R should not be equal to 1. That you can see from the denominator. If R is equal to 1, this will become 0. And if it is 0, it means it will be in the indeterminate form. Here also 0, here also 0, 0 by 0, that becomes your indeterminate form. And that's why we say R should not be equal to 0. So this is the sum of n terms as an AR to the power n minus 1 upon R minus 1. Now here, if you consider R less than 1, suppose R less than 1 and n tends to infinity, n tends to infinity, in that case what will happen? R is less than 1 and n tends to infinity. So 1 by 2 to the power infinity, that will tend to what? 0. Anything which is less than 1, and if it is raised to power infinity, the denominator will keep on increasing. That will get multiplied. The numerator will remain constant. In that case, denominator will become a very, very large quantity. 1 divided by very, very large quantity, that tends to what? 0. It means 1 upon infinity, because 2 multiplied how many times? Infinity. So it becomes 1 upon 2 to the power infinity. And 1 upon 2 to the power infinity, that will tend to 0, because 2 to the power infinity tends to infinity. So here, so this will be considered only when r is less than 1. If r is greater than 1, in that case what will happen? R greater than 1, then r to the power n, when n tends to infinity, that will be a very, very large quantity. So in that case, this relation will not hold true. So r should be less than 1, n tends to infinity, so it means this becomes what? 0. This term will be 0. So it becomes a divided by r is less than 1. So we will consider what? 1 minus r. R is less than 1, so in that case, you can write it as the same relation as a 1 minus r to the power n upon 1 minus r. This is when r is less than 1. So a 1 minus r to the power n upon 1 minus r. So this tends to 0, 1 upon 1 minus r. So finally you will get what? A upon 1 minus r. That is, r is your common ratio. So in that case, sum of infinite terms. When we say n tends to infinity, it means sum of how many terms? Infinite terms. Sum of infinite terms, provided r is less than 1 or mod of r less than 1. When we say mod of r less than 1, only r lies between what? Minus 1 to plus 1. So in that case, it becomes a upon 1 minus r. So sum of n terms in general, it is a r to the power n minus 1 upon r minus 1, and sum of infinite number of terms, provided r is less than 1, it is a upon 1 minus r. The other properties you can see, if each term of a GP is multiplied or divided by same non-zero quantity, the resulting sequence is also GP. If you multiply or divide by the same number, obviously the common ratio between the two numbers, the amount of the common ratio, that will change, but the nature of that sequence, it will not change, and that's why it will remain same as in GP. So we have considered just the basic definition of arithmetic progression, geometric progression, how to calculate the nth term of this sequence, how to add and how to calculate sum of n terms of this sequence when the terms are in arithmetic progression or geometric progression. So we will continue our discussion in the next video. We will define the harmonic progression, we will define arithmetic mean, geometric mean, harmonic mean, and all that, and then we will calculate the sum of any series. Like right now we have considered sum of n terms in GP, sum of n terms in AP, but how to calculate sum of n terms or sum of any number of terms if it is either a combination of arithmetic or geometric progression, or it is neither AP nor GP, it may be something else. Then how to simplify those kind of. So there comes a new method that is termed as summation of series. That summation of series is applicable for any situation, whether it is in AP, GP, HP, or any other sequence or series, whether the order is not followed, where any strict or any order is not followed. So in those type of series also, we consider summation of series and we try to simplify the problem. So all this we will discuss in the next lecture. Thank you.